Order mattered. You had to go in a specific order. When you're picking, how many ways you can arrange winning the ski jump? Someone first place, second place, third place. Order mattered. You were using the permutation one. When you do combinations, it kind of goes all out. The order doesn't matter. You're just combining all possible outcomes. Combinations can be a little bit messier because there's other things you have to worry about. Okay? When you start going into it a little bit further. So combinations are when order doesn't matter. We're going to work with combinations today, and that's kind of like the permutation stuff we did yesterday. Well, tomorrow we'll talk about it in terms of what's called the binomial expansion theorem and how you can use combinations to work with coefficients of binomials. That's like your junk square, don't kill a puppy, that kind of stuff. So we'll look at that. But today we're going to be talking, start bringing up decks of cards again, just because it's kind of an easy visual. So like I said, combinations are ways that you can pick certain things out of a what is it? They call it selection of R objects from a group of N objects. Basically, how many ways can I deal 5 cards out of a deck? So before I get into working with cards, I'm going to go out on a limb and hope that everybody understands deck of cards. Does anybody not know all specifics about a deck of cards? No, it's okay. If someone doesn't know, I'll show you. No. Yeah, there's 52 cards, 13 of each suit. There's 4 suits.
Plus 2 jokers.
I don't have those in here. I've already said that. There's no jokers. All right. So, if I wanted to deal 5 cards, how many different combinations can I come up with just dealing out 5 cards? A lot. Wow, you just got straight. I almost got it straight there.
Almost. That's good. Oh, did you say almost or you did?
7, 8, 9, 10, queen.
It's JQK.
What's that?
It's JQK, not Q's and it says straight.
Well, I know I said almost.
Oh.
Almost a straight. Left seems to jack. That was the ace.
You get 2 points.
Got there. Way up. Anyway, so what we're looking at here is we're using N choose R. There are, what this stands for is N factorial over N minus R factorial times R factorial. That's what that stands for. If you write that out longhand, how many different combinations do I have of dealing out 5 cards? It'd be 52 cards, choose 5. That's kind of how it's set. Long form, that's 52 factorial over 52 minus 5 factorial times 5 factorial. That gives me 47 factorial. You agree? So longhand again.
What's this E6 3.103479 E16?
It's just a, it's like a scientific notation style. What you see here is that the 47 factorial drops, and you wind up with this part over this part. You're not going to be doing this by hand because there is a calculator button for it. It's the same spot that permutation button was yesterday. In this case, I hit 52, math, left, number 3, choose 5, and hit enter. So I have, what is that? 2,500,000, yeah, a lot. There's a lot of different cards I can deal out. Okay, there's that many out there. So what we're looking at doing here, and this is pretty funny, is when we deal with our deck of cards, I can get this to work better. Oops. 2, 10.
Oh, is this solitaire?
No, I'm just dealing cards. There's one hand.
You got one card.
Oops. Doesn't want to work very well. Oh. Whoa. Ah. What's really cool though is that there is a random. Where is it? A random generator.
Oh.
Look what the random generated me.
What?
Set me a flush. That was only like the third time I pressed the button too.
Again.
I don't want to get rid of that. Are you kidding me? I'm staying on that hand. I'm not going anywhere. I'm betting it all.
How many things did you do?
3. This was the third hand that I got. Okay. So, oh, that's my hand.
Terrible. I need space.
Why don't you like screenshot it?
Too late now.
You're getting nothing.
I'm getting nothing in a. Oh, I got a pair. 2 pairs.
Is this right? No.
Did you find a lot of
No, that website's been shut down. I don't know. It's very sad. So anyway, we can do this all day. Let that be boring.
Oh, there you
Ah.
Ah.
Try to get lawyers to.
This is getting kind of boring. Yes. Anyway, so yes, probably. So let's take a look at this then. Let's start mixing this up to make it a little bit more difficult. And how many of these hands, of the possible hands that I was working with there, would I be able to get that flush?
Well, it's 25%.
We're not doing probabilities. We're not doing any probabilities. We're just counting possible outcomes. This is just counting outcomes. This is all this is. In how many of these hands can I get that? So what we're looking at here is you have to start thinking about more than one thing that can occur. In this instance, we're looking at how many of these hands, the hands that I was choosing 5, could I get the all the cards to be in the same suit? Well, how many suits are there? 4 of them. I want to choose one of them. How many cards of that suit would I be picking then? 1. 5 out of the 13. So what I have to be able to do here is you have to kind of delve into this a little bit longer. This is why I said that combinations tend to be a little bit trickier than permutations. You pick one of the 4 suits. You got to choose a suit to go with. It doesn't say that you're picking a specific one. You're just choosing one of the 4. Once you do that, then you have to multiply it by, well, there's 13 cards. I need to pick 5 out of them. Once I get the suit, whichever the first card I flip over, diamonds.
No.
If I get it wrong, if I get it right, you guys have homework. If I get it wrong, you have homework. Spade!
No.
Spade!
Yeah.
There you go.
Clubs.
I win.
That's the club. Duh.
All right. So when you go to your calculator again, you can set this up directly in your calculator by typing it. They're so cold. Was it 4, choose 1? times.
I'm Smurfy.
Hey, we're doing card tricks.
Oh, fun.
We're gonna teach them how to gamble.
Who's that?
Chris Smurfs. You guys put it right in your calculator like that, and it'll spit it out for you. How many possible outcomes did you get? What you're doing here is how many set of 5 cards can you draw that are of one suit? Is what you're looking at
What's
there.
the last number?
13, choose 5.
Wow. That's so you have less than like 1,000, or you have like 1,000% chance of getting a flush.
So 4%.
Well,
0.001.
not necessarily, because probability is completely different than counting outcomes here. Because you want to think of, you have to be able to figure out how many possible outcomes of getting a flush are there over the total outcomes that you could get. So, okay, so this would be getting your flush over all possible outcomes. So did you divide that by that 2 million?
Yeah.
Okay, so all right, so yeah, you're all right. I thought you were saying something different.
No.
But we'll get into that whole probability stuff of a lot of this stuff later.
0.000.
Now, what happens a lot of times with combinations, you can have a problem like we just did where we multiplied 2 things together because you wanted 2 specific things. You wanted to have the same suit and of the 5 cards there. When you get into this a little bit further, you might have to do adding or multiplying. And it's very easy to tell how you set it up after you read through a couple of the questions. For example, when you're trying to find the number of ways that a certain thing or something else could happen, that's when you're going to add. When you're trying to figure out when 2 things, when you want event A and another thing to happen, that's multiply. The or is an add, the and is a multiply. It's pretty straightforward when it gets into that. So let me show you how this works off a restaurant menu. When we're dealing with restaurant, let's say you're going to go order an omelet. And you're going to order 2 toppings from the vegetarian and 1 topping from the meat. So you're having an omnivore omelet. So you're choosing exactly 2 from the vegetarian and 1 from the meat. Well, when you choose 2 out of the vegetarian, how many vegetarian options are there? 6. So in that case, it'd be 6, choose 2, and 4, choose 1. That gives you total possible combinations of omelets you could order if that was your restriction. Okay? Does that make sense how that works out?
Yeah.
You're choosing, you take 6 of them, there's 6 options, choose 2 of them. There are 4 options, choose 1. 60, yeah. You get 60 when you multiply that out. Now, the difference is when you go to the other one, suppose you only have enough money to order at most 3 ingredients. Doesn't matter which ingredient you're ordering, but you can only get 3 of them. So that means you can have 3 ingredients, 2 ingredients, 1 ingredient, or nothing. In other words, you're just ordering an egg. It's a non-scrambled scrambled egg. An omelet. All right, an omelet is scrambled, but it's not like it's all mushy. It's like a it's a pancake egg. I like a fried egg. I do a fried egg. So in this case, this is the one where you would have to add them all together because you could take all your different options that you have. There are 10 total options there of all the ingredients. You could choose none of them. You could choose 1 of them, 2 of them, 3 of them. So you have to find those 4 specific scenarios. You start with 10, choose 0, plus 10, choose 1, plus 10, choose 2, plus 10, choose 3. You find out all of those independently, you just add them all up. You could string it all together if you want in your calculator. It's not a big deal. It's just it will do all that work for you. Okay. The difference here is I just want you guys to see what the wording looks like when you're choosing between multiplying or adding. Yes, ma'am.
So because it says at most, we know they're not picking just 3, they could pick 2 more 0.
Correct. If it said at least 3, that means that we'd be picking 3, 4, 5, 6, 7, 8, 9, or 10 of them. All right, so we just go in the other direction. Not bad. What'd you guys get for that one? What is it? Yeah, 176. That's what we got last hour.
Let me see.
Oh, I see.
So there's 176 different combinations that you come up with. Now do you see what they're doing when you go to Subway? All the different choices that you have? Now you can see how it compounds out to be a huge amount. You could choose all the different types of bread. And this is all and stuff. You have to get bread and a meat or this and that and that and that. You have
Subway,
it works out to be quite a large.
Oh, yeah.
Sometimes it's easier to subtract with these combinations than it is to add them. It's not a total necessity to be able to subtract because a lot of times since this book was written prior to most people having the calculators with these buttons, you had to do a lot of this by hand. What's that? Late 90s, I believe. It's a pretty old book. So let's say you have, there are 12 different plays. You want to attend at least 3, and this is what you were asking about a second ago, Shay. If you're going to attend at least 3, that means you can attend 3, 4, 5, 6, 7, all the way up to 12 of them. Now, if you're going to go to a play, how many different outcomes are there if you're going to go? Well, you're either going to go or you're not going to go. So how would you figure out the total number of outcomes for 12 plays? Well, remember, there's 2 choices here.
24.
Hold on. You're either going to go or not go 12 times, right? Oh.
What is the question?
What is the question? You're either going to go or not go 12 times. So how many options do you have? 2, 12 times, right?
Times 3. Go, not, go or not, go. Yes or no would be a easy one then. Oh. Technology, man.
You're going or not going 12 times, right? So when you set that up, it's either, there's 2 options here, 12 times. 2 to the 12. You're either going to go or not go. Now, if you want to attend at least oh well. I know, sorry about that.
What's the next one?
If you're starting out with the go or not go 12 times, if you want to go to at least 3 of them, one of the things you could do was 12, choose 3, plus 12, choose 4, and so on, all the way up to 12, choose 12. That's a lot of buttons. But it's worth it. But you could go the other way. What are the only other options that you have left here? You could not go to any of them, 1 of them, or 2 of them. So you could subtract 12, choose none, 12, choose 1, 12, choose 2.
Oh, you can subtract.
Less buttons, but still a lot.
It's still less buttons, but the idea here is if you think back to when you didn't have the calculator, if you had to write this out and simplify your fractions and multiply things through, it got really messy. That's why they use some of the subtraction stuff. Okay. You start with your total amount and just back yourselves out. It's very, very common for probability stuff later on. It's very common setup. It's not the world's craziest stuff to work with, but you can get lost rather quickly in the vocabulary of just looking words and what they're asking. What was it? That sounds right. I think that's what the answer was. Okay. Try these. They're going to be a little messy to start with because it's going to make you think. There's a handful of them at the very end that have, it's either permutation or combination. Tomorrow we will get into the binomial expansion. Again, what I mean by binomial expansion is it starts out like this, where you have x plus 4 quantity squared. You guys would write that as junk times junk and then FOIL out and go through all that. Well, we're going to find a shortcut that'll allow you to do this without having to multiply it off by hand. And it uses the combination stuff. Yes, sir?
Check my grade.
Yes, sir? You didn't write it down? It's up over
Yesterday
there.
it was 7 squared.
Give those a shot. Try not to overthink a lot of it.